In this lesson with our circles, we're now going to start looking at central angles, which are literally angles in the center of the circle, and arcs, so arc measurements. We'll also bring in chords as well, along with the arc measurement. So here, when we discuss again the central angle, the angle of the vertex is in the center of the circle. Now, this could create what's called a minor arc, which is going to be equal to the central angle. So if the angle, let's say here, is 70 degrees, then the minor arc here created is 70 degrees. So now the major arc is basically going the other direction. So if you notice, it's like it's greater than 180. So we're going to subtract from 360 because remember, a full circle is 360. So again, if this angle is 70 degrees, the arc it's creating, right, is 70 degrees, which means the major arc here, so the measure of arc, ABC, is going to be equal to 290 degrees from 360 minus 70. Then the semicircle is always equal to 180. So again, cutting the angle in half, or cutting the circle in half. So basically, if you notice, what does EG then have to be to create a semicircle? The diameter. So it has to go through the center and cut the circle in half. So example 1, we're going to look for X, Y, and Z. Now we're only given this central angle here, right? So notice in circle A, we have an angle measurement of 20 degrees. So that means X is 20 degrees. That means Y. Well, again, notice how here we have the diameter, which is creating 180 degrees. So if X is 20, then Y is 180 minus that 20. So Y is 160 degrees. So if Y is 160 degrees, then Z, if you notice, is the central angle that also creates that arc, which is 160 degrees. So keeping in mind that relationship. Now, let's look at 1B. So here we're given these two measurements of these two arcs here, two minor arcs. And notice we have these two markings, which means what can we say about and the 60 degree, my fault. What can we say about these two angles? They're congruent, right? They're equal to each other because they have that marking. So keep that in mind. So we're going to look for the measure of angle RPQ. So RPQ, which is this central angle here, which creates this minor arc RQ. So that means RPQ is 154 degrees because it's congruent to the arc it creates. So now let's look for SPQ, the measure of angle, SPQ. So SPQ. So now notice we're looking for this entire angle. So that means now we've got to figure out what is this missing piece. Well, if these two are congruent, then we can look for this section here. This is what's missing. So what could we do to find this missing section? Well, we know we have 86, 154, and 60. So we could add these three up, then subtract from what? 360. So go ahead and pause the video and make sure that you can get the measure of angle SPQ on your own. Let's see what you think. So this missing piece here is 60 degrees. And then you can check and make sure that all of these sections now add up to 360 degrees. So now we can find the measure of angle SPQ because this central angle is what creates this arc here. So you should have gotten 146 degrees from adding these two arcs together. So then here, the last one, the measure of arc, ST. So ST is here. Well, we just figured out that this arc is 60 degrees. So what can we do to find ST? Divide by 2, because these two pieces are congruent, making arc ST 30 degrees. Go ahead and pause the video and try the U-try on your own. Here we go. Now, as long as you identified maybe the percentages, and if you didn't remember how to actually then convert that to find the amount of degrees, then I'll show you. So then if you need to, repause the video so that you calculate the degrees, the amount of degrees for the other two here. So like the measure of angle, FMC. So FMC. So notice how we have these three sections, right? The 9%, 10%, 11%, which is 30% of the circle. So to calculate percentage of the circle, you are going to multiply that 30%, or remember this is 30 out of 100, right? Which is 0.3. And you multiply that part by the total number of degrees. Well, what's the total number of degrees in a circle? 360. So then what is the measure of angle FMC? 108 degrees. So 30% of the circle is 108 degrees. So now if you're like, oh, I remember now, but didn't do that, go ahead now and take the percentages that you found, pause the video, and let's see how you do. And here we go. So here with arc AHB. So AHB. Now option 1, you could add all of these up, or I notice if this is supposed to add up to 100%, right? Well, what's not included? This 25% section here. So that means adding all these up, or just subtract 25 from 100, we're at 75% of the circle. So that means I need 75% of the circle, sorry, 360 degrees. So 0.75 times 360. So here you get 270 degrees. So now the measure of angle EMD. So EMD here is, here. So just this piece, which represents 10% of our circle graph. So again, 10% or 0.1 times 360. So that means this is 36 degrees. So now our second concept with our central angles and arcs is we're going to now include the chord. So here, if we have congruent arc, so like here, for example, UV and ST, then if I were to create a chord ST, then technically this distance is also congruent to chord UV. So same thing goes, if you're given congruent chords, then the arcs that are created are congruent to each other. So again, the central angle, the arc, if they're congruent, then the chord is congruent, and vice versa. If you're given a chord that is congruent, then the arcs are congruent to each other. So like here, notice how we're given two congruent chords because of the marking. That means that the arcs are also congruent to each other. So if we're going to look for the measure of arc, WS, so we're looking for the measure of the arc, right? That means how can we solve for n? Set them equal to each other. So 9n minus 11 is equal to 7n plus 11. Now we're just solving a multi-step equation. Gather the variables. So now we've got 2n minus 11 is equal to 11. Now you're just solving your two steps. So adding 11 to n is equal to 22, and n is equal to 11. Now, is 11 our final answer? No, because remember, we're solving for the measure of the arc. So 7 times 11 plus 11 gives you 88 degrees. That is the measure of arc WS. So now here, we're given that these two central angles are congruent to each other, which means the arcs are also congruent to each other, which means the chords that are given to us are congruent to each other. So if we are looking for the length of NM, this chord, we're looking for NM. Well, how do we solve? We can set them equal to each other. So 14t minus 26 is equal to 5t plus 1. Then again, make sure to gather your variables, right? So I'm going to subtract 5t here from both sides. Now we've got 9t minus 26 is equal to 1. Now you're just solving your two-step. 9t is equal to 27, and t is equal to 3. Is 3 our answer? No, because we're looking for the length of mn, which is 5t plus 1. So 5 times 3 plus 1, so the length of nm is 16. Go ahead and pause the video now and do the U try on your own. And here we go. So these two circles are congruent to each other. CD, the chord, is congruent to EF, which means the arcs created are also congruent to each other. So to solve for arc CD, set them equal to each other. So 25y is equal to 30y minus 20. Now, I'm going to gather whenever I have a variable by itself. If it's alone, it wants to be alone, right? Leave it alone. So I'm going to gather and subtract 30y from both sides. And here I get negative 5y is equal to negative 20. So now when you divide, you get y is equal to positive 4. Now is for our answer? No, because we're looking for the measure of arc CD, which is 25y. So 25 times y, or 25 times 4, is 100 degrees. That is the measure of arc CD.